Welcome to Statics Lectures by Civil Thinking, and today we are going to solve a problem on friction on rough inclined planes. For better understanding, I suggest you to please watch the video lectures on friction one by one so that you will understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the problem. A horizontal bar 10 feet long and of negligible weight rests on rough inclined planes as shown in figure. So this is a figure. If the angle of friction is 15 degrees, how close to B may be the 200-pound force be applied before motion impends? And these are the four options, and we have to select the correct option from them. Now, as you can see here, we have a horizontal bar of blue color which are standing on two inclined supports, right? Now the supports are inclined and there is also friction. Now let us say the distance between this 200-pound and B is x. So we have to find this x distance before the motion impends. So what does it mean? We will find the value of x. Okay, we will find the value of x corresponding to the static equilibrium. Okay, static equilibrium. What does it mean? Now we will assume a location of x. We will assume the location of 200-pound such that there is no motion. That is, there is static equilibrium. Now when the x value is more or less than that value, then the motion will impend. All right. So what we are going to find, we will find the value of x, or we are going to find the distance of 200-pound from B such that there is static equilibrium. Okay, and when the x value is less or smaller than greater than that, then the static equilibrium will get disturbed and the motion will impend. Right. Now static equilibrium means we have to find three things, right? We have to find summation of moment about any point A or B equal to 0. We had to find summation of forces in the y direction is equal to 0. We had to find summation of f of x in the x direction is equal to 0. Now these are the three equilibrium equations. We have to apply these three equilibrium equations. When all of these are equal to 0, it means there is static equilibrium, right? Now before we apply these three equations, let us uh, find some values. Now angle of friction is 15 degrees. So we know the coefficient of friction mu is equal to tan of angle of friction, right? Angle of friction is 15 degree, right? Because this is the formula we got from earlier classes, right? Now mu is equal to tangent of 15 degrees. When you solve it using the calculator, you will get mu to be approximately 0.268. So we get the coefficient of static friction here. So let me erase all of this. Now when you apply these two forces on this bar, there will be reactions on supports A and B, right? Now there will be normal reaction at A and normal reaction at B. So let me draw the reactions here. Let us say this is normal reaction at A and this is normal reaction at B, because normal reactions are normal or perpendicular to the surface, right? This is the surface and normal reaction is normal to this surface, right? Now because it is said that the planes are rough, right? Rough inclined planes. What does that mean? It means there will be a friction opposite to the motion. You see, this bar is trying to move downwards, right? So there will be a friction in this opposite direction, which is equal to mu times Na, right? Because we know force of friction is equal to mu times normal reaction, right? So where mu is the static coefficient of static friction, right? Similarly, the bar will try to move downwards, so there will be a frictional force like this, which will be equal to mu times nb, right? Now, since this is 30 degrees, if you draw a line here, this is 30 degrees, it means this is also 30 degrees, right? This is 30 degrees, it means this is also 30 degrees. Now, let us resolve this Na in the x direction and y direction. Let us assume the vertical direction is y direction, y axis, and the horizontal axis is x axis. So this is Na times cos 30 degrees, cosine of 30 degrees, right? And we will have a horizontal component like this. It is going to be Na of sine 30 degree, right? Similarly, we will resolve this force due to friction mu Na into x and y component. Now, in the y component, the component will be like this, right? This is going to be, now this is 30 degrees. It means this is also going to be 30 degrees, right? This is mu Na cos 30 degree, and there will be a vertical component of mu Na, which is going to be like this, mu Na sine of 30 degrees, right? Now similarly here, this NB will have two components, NB cos 30 degree here, and here is going to be NB sine 30 degrees, right? Similarly, now mu NB, it will, when we resolve it, this is 30 degrees, right? Alternate angles, because this is 30, it means this is also 30 degrees. Here is going to be, let me erase this first. This is going to be mu NB cos 30 degree, and we will have a normal component here, mu NB sine of 30 degrees, right? Now these are all the components. I hope I didn't mess up, I didn't confuse you. I hope you understand everything. Just relax and resolve this Na into two components. This is the vertical component and this is the horizontal component. Then we find the components of mu Na. In the x direction is this, and in the y direction is this. Similarly, we resolve each force into x component and y component. All right. Now let's apply summation of moment about any point. Let us choose a point A. Okay. Now summation of moment about A is equal to 0. Okay. We'll apply this. After that, let me erase this first. Then we are going to apply summation of force in the y direction is 0, and then we apply summation of force in the x direction is 0, right? Because these are the three equations of static equilibrium, right? So let's first apply this one. Now let's assume clockwise movements to be positive. Now 100 pound is going to exert a clockwise movement, so it is going to be 100 multiplied by 2 feet. Now 200, how far is 200? Now from the total is 10, okay, and this is x. It means from here to here it is 10 minus x, right? So it is 200 will also exert a clockwise movement, so it is plus 200 multiplied by 10 minus x, right? All right. Now we have NB cos 30 degrees, as you can see here. This will exert what? It will exert, it is upwards, right? This is NB, and NB cos 30 degrees upwards like this, right? So it is going to exert anti-clockwise movement. So it will be negative NB cos 30 degrees. How far is NB cos 30 degree from A? It is 10, right? Now then we have this mu NB sine 30 degrees. It is upward, so it is going to exert an anti-clockwise movement, right? So it is negative mu NB sine 30 degrees multiplied by, how far is this mu NB sine 30 degrees from A? It is 10, right? 10 feet multiplied by 10, right? Now this nb sine 30 degree, this arrow is passing through point A. Also mu nb cos this 30 degrees is passing through point A. This is also passing through point A. All of these are passing through point A, so I will ignore them because moment due to these, all of these will be 0, right? So let us equate it to 0, right? Because summation of moment is equal to 0, okay? Now when you simplify it, you will get 200 plus, now it is 200 multiplied by 10, which is 2000, then 200 multiplied by x, but there is a negative, it is minus 200x, right? Then we have minus nb cos 30 degree multiplied by 10, right? Minus, let me calculate cos 30 multiplied by 10, how much is it? Let me use the calculator. Cos 30 multiplied by 10, it is 5 root 3, okay? Now we have 5 square root of 3 multiplied by nb, negative. Now this is mu, and the value of mu is 0.268, okay? I will multiply mu with sine 30 and 10, okay? I will calculate these values. So let me see, let me use the calculator. 0.268 multiplied by sine of 30 multiplied by 10. Okay, I get 1.34, negative 1.34. Then we have nb, right? Nb is equal to 0, right? Now 200 plus 2000 is 2200. 2200 minus 200x. Now let us find, let us keep nb common here, negative nb. It is going to be 5 square root of 3 plus 1.34, right? It is equal to 0. Now how much is it? 5 root 3 square root of 3 plus 1.34. Let me use a calculator. 5 square root of 3 plus 1.34. 1.34, it is approximately equal to 10, okay? This is, all of it is 10, so it is minus, it is 10 here, okay? So it is 2200 minus 200x minus nb, okay? So let me erase all of this first and I will write the equation very clean. Summation of moment about A equal to 0. What does it give? It gives 2200 minus 200x minus, this is nb 10. I will rearrange it like 10 nb is equal to 0. Okay, let us call this as equation first. Okay, so let me erase all of this. Now we have applied summation of moment about any point is 0. Then we will apply summation of force about y-axis is 0. Okay, so let us apply this. Summation of force about y-axis is 0. Now I have told you the upward forces in the y direction is positive and the downward are negative. So this mu na sine 30 and na cos 30, they are both upwards, so they will be positive. Let me write na cos 30 degrees, right? This, then I will add up this plus mu na sine 30 degrees, all right? Then nb cos 30 plus nb cos 30 degrees, then mu nb sine 30 plus mu nb sine 30 degrees. Okay, all of this is 0. Is there any other equation in the y direction? Okay, I have written this, also this, also this, also this. Yes, there are 100 pound and 200 pound downwards, so I will have to write this. Now they are acting downwards, so they are negative. Minus 100 pound minus 200 pound, right? 100 pound and 200 pound is equal to 0. Okay, now let me simplify it a bit. Now Let us put Na common here. It is going to be cos 30 degrees plus mu sine 30 degrees, right? In these two terms, I put Na to be common. So plus, now I will put Nb common in these two terms. Nb multiplied by cos 30 degree plus mu sine 30 degrees. Okay, then minus 100 minus 200 is minus 300. It is equal to 0. Okay, now we have cos 30 degree plus mu sine 30 degree. Cos 30 degree plus mu sine 30 degree. Now mu is 0.26, so let me put the value. Cos 30 degrees plus mu is how much? 0.268 multiplied by sine 30 degree, sine of 30 degrees. All right, it is 1. Okay, so this is 1, all of it. This is 1 and this is also 1. So what I get? I get Na plus Nb. Now minus 300 is equal to 0. When I move this 300 to the left, what I get? Na plus Nb is equal to 300. Okay, so I will write here summation of force about y-axis is equal to 0. What does it give? It gives us Na plus Nb is equal to 300, right? So let me erase this first. Now we will apply summation of forces in the x direction to be 0. Summation of forces in the x direction to be 0. Now this mu Na cos 30 degree, it is negative, okay, because it's opposite to this, right? It is opposite to this. This is positive and opposite to it is negative. So it is negative. Now Na sine 30 degree is towards the right, so it is positive. So I will write minus mu Na cos 30 degrees, right? This term. Then I will add up this term plus Na sine 30 degrees, right? Then is there any force component in the x direction? Yes. Nb sine 30, it is towards left, so it is negative, right? Minus Nb sine 30 degrees, right? This term. Then we have mu Nb cos 30 degree. It is towards right, so it is positive, plus mu Nb cos 30 degrees, right? This theta is 30 degrees, cos 30 degree, cos of 30 degree. Is there any another component, force component in x direction? Okay, I have applied this Na cos 30 sine 30 degree. I have also written this. I have also written this. I have also written this. I think there is no another component of forces in the x direction, so let me equate all of it to be 0. Okay, now let's put Na common here. In these two terms I will put Na to be common, so it is sine 30 degree minus mu times cos 30 degrees. Then let's put Nb common here, negative Nb. Okay, I will put negative Nb common here. Then it is sine 30 degrees minus, because here it is positive, so negative and negative will be positive, negative mu Nb, not Nb, Nb is common already, minus mu cos 30 degree. It is equal to 0. Now sine 30 minus mu cos 30 and sine 30 minus mu cos 30, okay, it is equal to 0, so they will cancel out each other. So Na minus Nb is 0. This will give us Na is equal to Nb, right? So summation of forces about x-axis equal to 0. What does it give us? Na is equal to Nb, okay? So let me erase all of this first. Now Na is equal to Nb, so let us put this Na equal to Nb here. Okay, now Na plus NB is equal to 300, right? I wrote this equation. Now NA is equal to NB, so I will put the value of NB here. Okay, NA is equal to NB, so I will write NB instead of NA because NA is equal to NB. So 2NB, NB plus NB is 2NB is equal to 300, implies NB is equal to 300 divided by 2. Now 300 divided by 2 is 150, right? So we get the value of NB, I will write here, NB to be 150. Of course it will be pounds, okay, because the forces are in pounds, right? So let me first erase this. Now NB is 150 pounds, so I will put the value of NB in equation first, okay, in this equation. So let me write 2200 minus 200x minus 10 NB, right? NB is 150, right? 150, it is equal to 0. So it is 2200 minus 200x. Now 150 multiplied by 10 is 1500. It is equal to 0. Now 2200 minus 1500, right? How much is this? It is 700, right? 700 minus 200x is equal to 0. So from here what I will get, 7. Now these two zeros and this 0 will cancel out, so it is 7 minus 2x is equal to 0, or 7 is equal to 2x, right? X will be equal to 7 divided by 2, right? 7 divided by 2, which is 3.5 inch, right? Oh, sorry, feet. So X is 3.5. So what does it mean? For the static equilibrium, the distance of 200 pound from point B has to be 3.5 inches. It means if the value of X is slightly greater than or equal to 3.5 inches, the static equilibrium will get disturbed and the motion will impend. Okay, so the minimum value for the motion to impend is 3.5 feet. Okay, so which option is correct? Option D is correct. Okay, so if you have any doubts, please comment. And this is how we solve the rough inclined plane problems. Okay, and that's it for today. See you in the next class. Thank you.